Okay, welcome to video 13.1, the last unit. We're going to be talking about the graphs of mixed functions today. So in this unit, we will remember how to graph some of the old functions and discover how to graph lots of new functions. So in the first one, we're going to graph and label what's called a parent function. Parent function is the most basic, so nothing has happened to it. So this parent function, f of x equals x squared, nothing's happened to it. And we're going to graph a second function, g of x, on the same set of axes by creating a table of values. So if I look over here, I need to first, since f of x, that's in function notation and it's in standard form, I can go ahead and find the axis of symmetry by using the formula x equals negative b over 2a. There is no b term, so it's 0 and a is 1, so then I can fill that in. Okay, and once I do that, negative 0, that's just 0, and 2 times 1 is 2. And 0 divided by 2 is 0. It tells me that 0 is going to be in the middle of my table. And remember, once we fill in the axis of symmetry in the middle of our table, then we go back 3 and up 3, and then we get our y values by putting this in y equals in our calculator. Now we look at g of x equals x plus 3 squared minus 2. We want to graph that too, but it's not in the right form. So we have a couple options. I can put it in standard form, and that'll tell me where the axis of symmetry goes through. And then we'll eventually learn a way that we can just use this without doing that to find the middle of the table. So let's go ahead and double distribute out. So when I write that out, x plus 3 squared, that's x plus 2 times x plus 3. So area model, and now I have these. I can go ahead and see on the side that I have these like terms, 3x and 3x, which will combine to be. So now from there I can see the a and b. So a is 1, b is 6, and I can fill it into my axis of symmetry formula over here. When I simplify that, it becomes negative 6 divided by 2. Which gives me my x equals negative 3. So my axis of symmetry is x equals negative 3. Now that will help me because I know that the x value of negative 3 needs to go in the middle of my table. And then I can again go back 3 and up 3 to fill in my table. And now that gives me my second table, which is the negative 6 through 0 and the y values paired along with it. So now that I have all of my work for both graphs, I'm going to go ahead and graph them at the same time. Now you could have, since we did the first one, you could have just gone ahead and graphed that and then moved on to the second one. But I'm going to graph them both at the same time. So negative 3 up 9, and we'll plot a point there. And then we'll continue with all the points in the table. So I started by graphing my f of x function, and then remember, since we're going to be graphing two things, we definitely need to have a label that tells us f of x. Now that we have that, I'm going to do the same thing for the g of x function. Okay, so we can see all we did was get the axis of symmetry. Remember that that's a key part of graphing quadratics. We found the table of values, plotted them, and connected with a smooth curve. Be careful not to show a vertical line because this is a function, so it doesn't go straight up. It continues to go outward and upward on both ends. And then we needed to label both of them. Because there were two functions on there, I absolutely have to label them. Since these were g of x and f of x, I can just label them as that, but you could also go ahead and label them with the entire function if you would rather. Okay, so we're going to do the follow-up questions in class tomorrow, but I'm going to talk to you about the roots before we leave this video. Roots, zeros, or x-intercepts. For the pink function, it's easy to see. There's one point that crosses the x-axis to find the root. For the brown function, it seems that g of x passes at a not-so-nice number. So to find that, I think we should use this original, but we want the y value to be 0, so we're going to replace this with 0 equals x plus 3 squared minus 2. My hint to you is that you do not have to do the double distribution. You can use this original and do the opposite of what happened to x in order to get it by itself. And we'll talk about this more in class. Have a good night.